We're going to go into constructing our own models from application problems. We're solving word problems. The very first thing to do is step one is to read the problem through until you understand what is given and what is to be found. You may need to read more than once. Draw a diagram to illustrate the problem if possible. If it's a geometry problem, you might need to draw the shape. It involves geometry shapes. It might draw a diagram with a motion problem of what's happening with the motions. Different things you can draw a diagram for. Once you draw a diagram, if you need it, assign a variable to represent the unknown value. Write down what that variable represents. If necessary, you might need to express other unknown values in terms of that variable. And sometimes a table might help you organize your work. Step 4 is to write an equation using the variable expressions. Step 5 is to solve that equation. Step 6, you need to check the answer in the words of the original problem. Does it seem reasonable? Does it work? And step 7 is to state the answer to the problem. And I do want labels on the answers. Here's a geometry problem. A rectangular room is 1.5 as long as it is wide, and its perimeter is 25 meters. Find the dimensions of the room. Now, since this is a geometry problem, the first thing I like to do is draw a picture of what we have. So here's my room. It is 1.5 as long as it is wide. So I'm going to let the width be x, and the length will be 1.5x. And its perimeter is 25 meters. So the perimeter is 25 meters. Well, I know the formula for perimeter is perimeter equals 2 times the length plus the width. Filling in the numbers they told us in the problem, the perimeter is 25. The length is 1.5x, and the width is x. Working the problem, 25 equals 2 times 2.5x, or 25 equals 5x, and x equals 5. And this was the width, 5 meters. Now they asked us to find the dimensions of the room, so that means they want both the length and the width. So I would say that this room is 5 meters by 1.5 times 5, 7.5 meters. I could check that answer in the problem. 5 plus 7.5 would be 12.5 times 2 would be 25. It checks. This is another geometry problem. Julia's soybean field is 5 times longer than it is wide. To increase her production, she plans to increase both the length and the width by 2 meters. If the new field is 46 square meters larger than the old field, what are the dimensions of the old field? Well, we have two fields. We have the old one and we have the new one. The old one we know is 3 meters longer than it is wide. So if this is the width, the length is x plus 3. 3 meters longer. Now, to increase the reduction is going to increase both the length and the width by 2. And so my new width would be x plus 2, and my new length would be x plus 3 plus 2, or x plus 5. And they talk about it being 46 square meters larger. That means it's an area. The area of the old field is x times x plus 3. And the area in the new field is x plus 5 times x plus 2. The new field is larger than the old field. What are the dimensions of the old field? The new field is larger than the old field. So the new field, the x plus 5 times x plus 2, is equal to the old field, x times x plus 3, plus 46. The new field is the larger one. Using FOIL to multiply this, I'll get x squared plus 7x plus 10. Removing parentheses here, I'll get x squared plus 3x plus 46. Getting my terms on the right side. Oh, if subtract x squared from both sides, those will be gone. So I'm going to subtract 3x from each side. I'll get 4x plus 10 equals 46, and then subtract 10 from both sides. 4x equals 36, and x equals 9. 9 meters. So 9 meters and 12 meters. So the dimensions of the old field would be 9 meters by 12 meters. That would have an area. The area here would be 108. Adding on, it would be 14 by 11, or 154 square meters. That would be 46 meters longer. It checks. Now here's a uniform motion problem. Maria and Eduardo are traveling to a business conference. The trip takes 2 hours for Maria and 2.5 hours for Eduardo, since he lives 40 miles farther away. Eduardo travels 5 miles per hour faster than Maria. Find their average rates. Well, when I'm doing a uniform motion problem, I usually set up a box and I say rate times the time equals the distance. And I'll fill in the information they gave me from the problem. So we have Maria and Eduardo. The trip takes 2 hours for Maria and 2.5 hours for Eduardo. He lives 40 miles farther away. Can't do that. Eduardo travels 5 miles an hour faster than Maria, and we're finding their rates. So I'm going to let Maria's rate be x and Eduardo's rate be x plus 5. And then I'm filling in the distance part of this problem by doing the multiplying. Rate times time equals distance. So Maria covers a distance of 2x, and Eduardo covers a distance of 2.5 times x plus 5. Now that's their distance, and what else do we know about their distance? We know Eduardo is 40 miles farther away. So Eduardo's distance, that 2.5 times x plus 5, must equal Maria's distance plus 40. That makes him live 40 miles farther away. Working this, I can get 2.5x plus 12.5 equals 2x plus 40. Subtracting 2x from both sides, I'll get 5/10 x. Subtracting 12.5 from both sides, I'll get 27.5, and x can turn out to be 55. And x is Maria's rate, so Maria goes 55 miles per hour, and Eduardo travels at that plus 5, so 60 miles per hour. Okay, 60 times 2.5 would be 150, and 2 times 55 would be 110. That's 40 miles farther away. So this is my solution.